Okay, hello my friends. So in this video, I'm just going to go through a few examples of volume using cross sections, just kind of the general idea. Okay, so in this video, I'm going to go through these two examples. You can pause if you would like to read the examples over, and if you want to fast forward to one, of course you can do that. I'm just going to go ahead and jump right into these. Okay, so the first example says the solid lies between planes perpendicular to the x-axis at x equals 1 and x equals -1. The cross sections perpendicular to the x-axis are circular discs whose diameters run from the parabola y equals x squared to the parabola 4 minus x squared. Find the volume. Okay, so with these problems, so even if your drawing is like a crappy drawing, you do want to have the drawing because it's going to help orient yourself. So I remember when I was learning this stuff, I just wanted to do this anyway without doing the drawing. And I think one of the issues was that like I was just worried that it wouldn't look very good. But you know what these two graphs look like, right? So, okay, let's just draw them. All right, so x squared looks like this. And then let's see, 1, 2, 3, 4. So 4 minus x squared is going to be something like this, okay? So here are the two curves that we're talking about. And then we're also told that the solid lies between x equals -1 and 1. So here's, let's say, -1 and 1. So I will just draw these little pink lines so that we can really clearly see this. Okay, so what we're talking about here is a solid that lies kind of in this region, okay? So that's what we're talking about, but I need to be able to see, so I'm going to get rid of that. Okay, so we're also told that the cross sections, so we've got a solid kind of going between here, and then we've got circular discs whose diameters are running, so we've got discs going through here. And you can think of these discs as like popping out of the screen. Okay, it's not a 2D drawing, right? We need to think of this as a 3D drawing. So I just want to point out my drawing's kind of crappy, and that's totally fine. It's something to orient me for what I need. Because when we talk about volumes of cross sections, so what are we really trying to get at? So I need to be able to fill in something that looks like this. Okay, so the A and the B, so these are going to be, in this case, since everything's in terms of x, this is going to be with respect to where my x's start and end. So in that case, it's going to be from -1 to 1. Then this part here, so this stands for an area formula for my cross sections. Okay, so to figure that out, we have to think about what the cross sections are. We know they're circular discs. So what's the area of a circle? So we've got to do a little bit of work for this. Okay, so the area, maybe I'll just write here for a circle. So that's pi r squared. Okay, now what's r in this case? So r is a little bit nuanced because we don't just have like, r is not just like 3, right? It's not like a number. The thing is that depending on where you are in this shape, so like if I were here, versus like over here, the diameter is going to change. So we have this dynamically changing diameter, and all we know is the diameter. I'm having trouble saying that word. So I need to take this equation now and manipulate it for the situation that I have. So I don't have a radius, right? I have a diameter. So how do I turn a diameter into a radius? Well, I take d divided by 2. So this is actually going to be the form pi d squared over 4, okay? All right, so we're getting closer. So now I just need to figure out a way to represent my diameter. And again, I don't have like a static number I can use here. So instead, my diameter is going to be the difference between whatever the top curve is minus the bottom curve. And in thinking of it that way, then I can kind of see how the diameter is dynamically changing depending on where I am in the graph. So my diameter then will be pi, okay, so diameter, so I want the top minus the bottom. So the top curve is this 4 minus x squared, and the bottom curve is just x squared. all of this has to be squared over 4. Okay, so appreciate this before we go any farther, because this is really the key. I took the circle formula and then I manipulated it for the situation. And the diameter, since it's running between here and here, I had to find the difference between these two, and I had to write this dynamic formula because this will allow then the size of the diameter to change depending on where we are in the graph. Okay, so if that part makes sense, now this is just a matter of kind of cleaning up the math. And there's a whole bunch of algebra that we have to do now. Like, we can't even integrate at the moment. So a lot of these problems actually come down to, 1, understanding, like orienting yourself with the picture, and then 2, like getting through a mess of algebra. So let's make a little space and keep going. Okay, so let's just sort out all this algebra, and I don't want to take up like a ton of time in this video, so I will just fast forward through the steps so that you can see them. Okay, so I went through and I ran out the algebra here. So here's what happens when I like FOIL everything out. All of these numbers are divisible by 4, so in the final answer I just divided everything by 4. So this is actually now what I need to integrate. So now we're in business, so I'll make a little more space. So this is going to be my AX. Okay, so now I can set up this integral. So we already said the x's go from -1 to 1, and then I've got pi, and I'll just write this in descending order because I think it looks prettier that way. Okay, and now this is just a matter of integrating this, right? So I'll go ahead and just fast forward through that part so you can just see the steps. All right, so I'm running out of room here. I didn't write the exponents here because 1 to the exponent is just going to be itself. So, okay, so let's finish this out. So okay, and so ultimately, when I just finish out all the arithmetic here, I get 86 over 15 pi. And so that's the end of that problem. All right, so the next problem has 2 parts to it. So the base of a solid is the region bounded by the graphs of y equals square root of x and y equals x. Find the volume when the cross sections perpendicular to the x-axis are either isosceles triangles of height 4 or semicircles with diameters running across the base of the solid. Okay, I really like these types of problems because I think these really help you to understand how important the cross section is. And so this is a really nice comparison. Okay, so in this particular problem versus the last one, so maybe I'll just go back to the last one for a second. So in the last problem, notice that like we were kind of given these really clear bounds, x equals -1 to x equals 1. So in this problem, we don't have that because it just says the region bounded by. So what that means then is that we have to figure out what are the bounds on it. So the first thing that we've got to do here is just graph it. And as we have discussed already, really important for you to graph this. So here's 1 and 1. So here's my square root of x. And then y equals x is just going to go through that point. So let's see. Let me actually try to zoom in on that a little bit more. Make this one and this one. So I want to just point out, so like when I made this video, I didn't really like plan it out in advance because I just want you to see like the thought process. The picture is really important. So notice that like I will redraw it just for the sake of better being able to visualize the area. If you fight this, you're going to make the rest of this harder. So, you know, even if your drawing's kind of crappy, as long as you can like interpret it, you're good to go. So I'm talking about now this little area here. And this is actually pretty easy to figure out the bounds of, at least. So this is just the point 1, 1. This is the point 0, 0. So now I'm talking about going from x equals 0 to x equals 1. So I've already figured out what my bounds are. And now we've got the cross sections. So the cross sections, I always think of it as like, here's kind of your shape, and then there's another shape popping out of it. And in the first one, it's an isosceles triangle with a height of 4. So kind of popping out of this, I have this triangle like that, okay? And so the thing is, depending on where you are, right, the base of this triangle, so the base is changing depending on where you are in the shape. So totally fine if your drawing doesn't look like this, but just something so that you can kind of visualize like what is happening here. So I know the height of the triangle, and so remember, the whole idea behind this is I'm trying to fill this in, where this AX is just the area formula for the cross section. So the area of a triangle is typically 1/2 base times height. Okay, so I know the height, right? We already said that the height is equal to 4. That was a given right here. So now I just have to figure out what the deal is with the base. And the base is changing depending on where we are in the shape, right? So if the base is changing, that's going to be figuring out this dynamic formula, kind of like we did in the last one. So my question for you would be to pause the video and see if you can figure that out. Let's test your intuition and then hit play when you're ready. So my base is going to be the top. It's always the highest minus the lowest. So here's the top piece, here's the bottom piece. So my base then, let's see, my area will be 1/2. So the base, let's see, it's going to be the square root of x minus x, and then all of that times 4. Okay, so that's our area. We figured it out. And so now I can just take this along with my bounds and plug it into my integral. So let's make some space. All right, so I'm going from 0 to 1. Here's my area formula. So it was square root of x minus x times 4 and then dx. Now, you always want to kind of clean up the algebra here. So 4 times 1/2 means that's going to be 2. So I can just bring the 2 out in front. And then I like to rewrite my roots with rational exponents. And so from here, now this is just a matter of just integrating. So this part I'll just fast forward through so you can see the steps. And of course, feel free to pause the video if you want to review them longer. I'm just trying to save time in the video. Okay, and so when all is said and done, so you can, of course, pause the video if you want to look over my work, but when all is said and done, I got the answer 1/3. Okay, so I kind of left the same drawing up, and now we just have that the cross sections. These are semicircles with the diameters running across the base of the solid. Okay, so now I have this semicircle, so the base is going like this, and then I've got a circle popping out. See that? All right, so what's the formula then for a semicircle? So a semicircle is, so a circle has area, oops, what am I thinking? I'm thinking of the triangle. Pi r squared. So a semicircle is going to be 1/2 pi r squared. And so then we have to figure out what the radius is. Everything is in terms of the diameter, so I just need to switch the calculation now to be 1/2 pi d over 2 squared. So that's going to all simplify to pi d squared. So this is going to end up becoming d squared over 4. 4 times 2 is 8, so we have an 8 in the denominator. Okay. All right, so now I just need to rewrite this diameter part, right? And that part is very similar to the trick that we used in the last problem. So that diameter can be rewritten as the top minus the bottom. So let's see. My area then will be pi square root of x minus x squared over 8. Okay, so I feel like you should know what to do from here, and so I would encourage you to try to just finish this and then hit play when you think you've got it, and I'll show the rest of it once you hit play. Okay, so I'm going to make some more space. Here's what I've got to integrate. I have a whole bunch of algebra I have to do, so I will just go ahead and fast forward through the algebra so you can at least see it. Pause the video if you would like to look at the steps with more time. Okay, and so when all is said and done, so I've got all my work here, this comes out to pi over 240. Okay, so if you found this video helpful, help me out and hit the like button, share it with your friends, subscribe to the channel. If you have other questions, you can always leave me a comment. And otherwise, I will talk to you guys in the next video. Thanks for watching.